Hello everyone, welcome back. So let's continue now and start implementing this inside of DOPS. And I'm going to put a time shift and freeze the SDF so I only have, so it doesn't have to recompute every frame. And I'm going to create a pop network and connect this into the second input. And let's delete this. I'm going to create a pop location. And let's move it up. Let me check. I'm gonna move it 70 units. High enough. Yep. High enough so that it interacts with Kong. And I'm gonna put down a gravity node. If we hit play, we get a nice source. And I'm gonna change a few things. I'm gonna add some more variants so it covers. We have more coverage. Cool. So let's implement the collision system. I'm gonna use a pub VOP. I'm gonna call this Kong collision. And we're gonna add a couple more features that we didn't implement in SOPs. So let's set this to point to the right inputs. So first, second, and so on and so forth. And let's go up and copy some nodes. It's the same node, so that's a very nice feature. I'm going to copy the volume sample, the compare, and let's start with the color. Let's just make sure our system works. So this. Let's go back. So we have a volume sample and a compare node and then a switch node to change the color from red to green. And I always start simple, make sure everything is working. And here it's matching the second input. That's why I connected this here. Let's hit play. Cool. So we know the points that we need to interact with. And let's do the remaining parts. So let's copy the volume sample with the gradient, the add, and the switch too. Let's go back, let's paste this. Okay. And we're going to plug that into P. So this is reading, the second one is reading our first position, and then we're changing it if it's inside the volume and doing the multiplication to offset the points. Now let's hit play, and boom, it's working. Now because we're just moving the points to the isosurface, there is no bounce feature or anything like that. And we can implement a fake collision, a fake bounce system. And what I'd like to do, if you guys remember from this example here, we moved the points, the amount needed to push them from whatever location they were in onto the isosurface. We can take that vector, we can take that same information and feed it into the velocity and see how that looks on the points, see how that changes the sim. So let's do that. I'm gonna copy this, okay, and let's disconnect this and disconnect this, and this is my result of the vector. So this is the gradient multiplied. I'm gonna just say, okay, if it's true, if the points are inside the volume, I want to use the same amount from here and add it into velocity. So this, I'm going to add it into the velocity field, the velocity vector, pardon me. And I'm going to plug this result out. Let's hit play. Okay, nothing is visible at the moment. So let's try and multiply this by a constant. Let's try 20. Okay, so something is happening now. And this is actually the bounce system working. And what we've done is we've taken the normals, the gradient information, and we've applied a percentage of that, a version of that, onto the velocity. We can keep increasing this amount as much as we want, and that's gonna control how strong the bounce is. Now it's too strong at this point, and if we set it to 5, it's working, you see here, but it's not too strong. So it's really up to the user to decide how much bounce they would like to see. But that's how you implement the bounce system. Now let me try and have the character move. I'm gonna reduce this so it's faster to compute every frame. And let's turn off the time shift. And let's hit play. Maybe by the time we're here, Kong is gonna be very far away. Let's see. Yep. Yeah. So frame 47. Yeah, Kong is here. So let's animate the source. Let's create a box. This is, I'm gonna set a keyframe here, and let's go here and set another keyframe after we position the source. Well, this is just a box, but I'm gonna copy the animation. It's based relative, and let's try. Maybe we need to increase the velocity or have the source be, yeah, I think it's still not gonna hit. No, there, it worked. Let's do one more thing. Let's increase the speed at which the particles are falling down. It's 20. Yep. No. Come on. Okay, just a tiny bit there, but you can see how it's interacting properly. Cool. So this is with just the, let me move this back to 0. This is just with the gradient idea. Now another thing that I personally like to do is to transfer some of the velocity into the points as well. And I'm going to use a volume vector sample to sample the velocity field. We did this before, but we didn't finish the example, and now we're going to implement it. So I'm going to sample the second input, and the primitive name is val. Okay, and instead of using this now, instead of using the gradient, I'm going to just use the velocity information, and I'm going to multiply it by a constant just to make sure that we're getting some result. So let's say 10, and let's hit play. Now the first frame of Kong, even though Kong is static, it has velocity and it's really high. So let's set it to 1. And it's working. So this is not a collision. This is not a bounce from collision. This is Kong velocity being transferred onto the points. Okay, and let's try something else. Let's do this. Let's create, let's disable this. I want to create a box that emits more points, or a grid. So here, and let's do a time shift. Okay. Okay, I hope it's gonna hit Kong pretty well this time. And we can fill the entire environment with points if we wanted to. But let's see this. So scatter. And I'm gonna connect this to the first input. Let's emit more points. And let's dive inside. I'm gonna change this to pop source. And all points from the first input, we're gonna connect this. And let's give it some more velocity vector. So add to inherit velocity, I'm gonna set all this to 2 and this to 10 so it shoots down much faster. And let's hit play. And I don't see any points. So make sure we set the first input, use first context geometry. Okay, I'm gonna disable the guide. And there we go. Obviously we're emitting a lot of points than we need, but you guys get the idea. Let's do this. Let's scale this grid. I want to really show this. Sorry, I didn't plan for the best visualization and I'm doing things live, so bear with me. All right. That's our Kong interacting, and that's the collision system. So this is pretty much it in terms of how we're going to implement the collision system, and this method works really well with any complex geometry. As you guys saw, doesn't matter how much how heavy it is, we just have to be careful with the volumes resolution, and maybe keep it around the 400 on each axis. And then we're gonna create SDF for the rigid body sim too, because we're gonna use that as part of the collision. So we'll continue setting this up in the next video. Thank you guys for watching, and see you in a bit.